Hello everyone, welcome to this video. I am Akshay and today we'll be discussing part B of my internal test paper, validity and reliability in feedback. It focuses on validity and reliability in feedback analysis. We'll explore statistical methods for analyzing student feedback data, covering four key questions that demonstrate different analytical techniques. Question 5. Let's begin with question 5, which asks us to compute dissimilarity between student feedback profiles. The main objective here is to measure how different two students are across multiple attributes. We need to compare feedback from two students, handle mixed types including nominal, ordinal, and quantitative variables, and apply appropriate distance measures for each. Let's move on to the next slide. When dealing with the student feedback, we encounter three types of data. Nominal data includes categorical variables like gender, male or female, or departmental codes. Ordinal data consists of Likert scale ratings ranging from poor to excellent. Quantitative data includes numerical values like age, test scores, or course duration. Each of these types requires specific handling when calculating distances. Distance measures 20 seconds. For question 5, we use three main distance measures. The Euclidean distance calculates the square root of the sum of square differences. This is the most common measure. Manhattan distance simply sums the absolute differences between attributes. The supreme distance identifies the maximum difference in any single dimension. The choice of measure depends on how sensitive we want our analysis to be the outliers. Let's now move on to the next slide. Question 6. Moving to question 6, we are given a student feedback matrix with five students labeled A1 through A5, each rated on four attributes. We have a new feedback vector X with values 4, 4, 3, and 5. Our task is to find which existing student is most similar to this new profile using distinct metrics for comparison. To perform the similarity analysis, we calculate the distance from our new vector x to each of the five students. The key principle is that lower distance indicates more similar feedback patterns. We then rank the students by their similarity to the new vector and identify which student profiles most closely matches the new feedback. Also, for the actual calculation, we apply all three distance formulas we discussed earlier: Euclidean, Manhattan, and Supremum to each student. This gives us three different perspectives on similarity. We then compare the results across all three methods to see if they agree on which the students is most similar. Question 7. Question 7. Firstly, another thing, finally, we rank all students from most to least similar to our new vector. This allows us to identify not just the closest matching student but also the most different student. Interestingly, different distance metrics may produce slightly different mark rankings, which tells us something about the nature of the differences between feedback profiles. Let's move on to the next slide. Question 7. Question 7 takes us into relationship analysis. Here we analyze the relationship between two survey questions by creating a scatter plot of Q1 versus Q2 responses. By visually examining this plot, we can identify whether there is a pattern in how students respond to these two questions and determine what type of correlation exists. Also, question 7. Once we identify the pattern type, we choose the appropriate correlation measure for linear relationship. We use persons R correlation coefficient for monotonic but non-linear relationships. So, Superman's Rahu is more appropriate. Both measure range from -1 to +3, where values closer to 1 or -1 indicate stronger relationships. We also assess whether the correlation is statistically significant. Let's see the question 8. Question 8 introduces Cronbach's alpha, which measures the internal consistency of our feedback questionnaire. This tells us whether all items in the questionnaire are measuring the same underlying construct. It's a crucial reliability measure that determines if our instrument is consistently measuring what we intend it to measure using a covariance based calculation. Now we'll see the calculation method. To compute Cronbach's alpha, we follow a systematic process. First, calculate the variance of each individual item in the questionnaire. Second, calculate the variance of the total scores across all items. Then apply the Cronbach's alpha formula which relates these variances. The alpha value ranges from 0 to 1, where higher values indicate better internal consistency. Also, interpreting alpha values. Interpreting convex alpha is straightforward. An alpha of 0.9 or higher indicates excellent internal consistency. Your items are very highly related, and alpha of 0.7 or higher is considered good reliability and is generally acceptable for research purposes. However, if alpha falls below 0.7, we have questionable reliability, suggesting some items may not be measuring the same construct. Now, to summarize part B, question 5 covered distance measure for dissimilarity analysis. Question 6 demonstrated classification and similarity ranking. Question 7 explored correlation and relationship analysis through scatter plots. And question 8 accessed reliability using Cronbach's alpha. Together, these methods provide a comprehensive tool for analyzing feedback, validity, and reliability. Thank you for your attention. And this brought us to the end of our video. Let's meet in the next video.